Okay. All right, so we're going to continue on with our discussion about producer theory. Okay, how the company makes decisions about what and how much to produce. Okay, remember the bottom line, it's always profit, profit, profit. Now, who remembers what's the difference between economic profit and accounting profit?
Economic profit is more like the economic side, and accounting is like the ones that we use normally.
Yeah, okay. So, specifically, the big difference is taking into account this idea of opportunity cost. So, the problem with opportunity cost is it's something we always have to think about, but it's not something that you're paying money for. It's what you're giving up on. So, let's say that we did this yesterday, but let's say that your economic profit is negative. What does that mean?
They used to stop doing it
Stop.
and go to the other.
Good. Okay.
Because
Because not earning, I don't even want to write it. You're not even earning back your opportunity cost. Okay. What if your economic profit is positive?
You're earning more than the opportunity cost.
Yeah, keep going. You're earning more than your opportunity cost. You're earning more here than you could be in your next best alternative. So it's in your best interest to keep on doing what you're doing. So every single person out there, every single firm wants to have positive economic profits. But
So it is
actually,
good to have a high opportunity cost.
yeah, okay. I mean, if you think about it, if your opportunity cost is high, that means you are very, very valuable. Okay, your next best alternative is something very, very high. So let's say for me, working at Zinkers, let's say my opportunity cost was, earning $20,000 at McDonald's. Man, that's a very low opportunity cost, which shows me that I'm not really all that valuable because that's my next best alternative. If I wasn't at Zinkers, I'd be working at McDonald's. It's not just one of my other options, it's my next best alternative. So that sucks. So you want to have a high opportunity cost. If I wasn't working at Zinkers, I'd be running my own company like Amazon, earning $10 million. Okay, so my opportunity cost is $10 million. That's super high, showing me that I'm actually a valuable worker. Okay, so you always want to be earning more than your opportunity cost. You always want your economic profit to be positive. But I'll show you this in a little while. Okay, it's actually best for society if economic profits are equal to zero. What that shows you is this company is just earning back their opportunity cost. What that means is they're just being as efficient as possible. Go ahead.
But isn't that like the perfect case?
Yeah. Okay, and we'll
Yeah,
see
we
soon
like that, of course.
that we'll call this perfect competition. This will be one of the key characteristics of perfect competition. What was the second part of your question?
Like, does it happen in real life?
Sometimes, okay. In some markets, in some industries, okay, it does happen. Okay, but not
Like,
usually.
if you're a CEO, I think. But like, if you're working at McDonald's or something like that,
Mhm.
you obviously want a better job.
Yeah. So, um, the the point here is whenever you're not at your perfect job, whenever, or at least for these companies, whenever there's negative economic profits, there's a reason for you to change your mind and do something else. If there's positive economic profits, we'll see this a little bit later on too. There's another reason for change to happen. So
we
it's when,
haven't done perfect competition yet.
oh, not even close.
Okay.
We're building up to that
Okay.
right now. Okay, but
Okay.
when economic profits are equal to zero, there's no more reason for change. Okay, and we'll see why that leads to a long-term, long-run equilibrium. Okay, well, good job remembering that. Now let's start moving into our different factors of production. Okay, so again, we're going to be talking about the short run first. Okay, the short run is when we have some fixed inputs and we have some variable inputs. All that means is some of our resources we can't do anything about, and some other resources we can do something about. So usually in the short run, for most companies out there, if we talk about labor and capital being our two most important resources, which one is usually going to be fixed?
capital.
Usually going to be the capital. You can't do much about your building. You can't do much about your factory space. It is what it is. But what you can do something about is change up vary your amount of labor. Okay, so for this, what we're going to do is we're going to be doing a ceteris paribus condition. We're going to be assuming that however much factory space you have, it's going to be fixed. We're not going to be changing that up. And what we're going to be doing is we're going to be changing up your amount of labor, and we're going to see how much output these workers are going to be able to do. Okay, so here in the short run, our story is actually fairly simple. You can't do anything about your capital. All we're going to do is try to change up your amount of workers. Okay, now remember here, we're no longer the buyers. We're no longer the consumers. We're the producers. So put yourself in the shoes of a company owner. Okay, and you need to think about how many workers to hire in order to produce however many products you want. Okay, so we're going to start coming up with some new variables. What does it look like that? What?
That looks double.
Yeah, it makes me think I'm going crazy. Let's close this off. And
Probably
let's
you
open
change
that.
your language to Chinese.
Is that what it is? Consumer producer theory. There we go. Oh, what page was that? Let's try page 10.
Before.
Okay, here we go. So a couple of short-run production measures. So the first thing is, remember, capital is, with a line over it, capital is fixed. Can't do anything about it. So let's see what we could do with the varying amount of labor. So the first thing we're going to talk about is something called the total product of labor, the TPL, total product of labor. Okay, and what that shows you is, with all the workers that you have, how much stuff, how much production are you able to do? So I'll draw it out for you here. If this is labor, we could talk about the total product of labor. Go ahead.
Like, when do companies experience like the short run, and when do they experience the long run?
Again, I can't give you a specific time period. I can't say 47 days is short run.
Like, what is an example of a company going through short run?
When they can't change up their factory space. It's just a period of time that one of their resources is fixed.
1 week.
It could be if they're able to build a new factory in a week. Okay, then during that 1 week, they're in the short run. But after that week, they're in the long run.
Is that TP1 or TPL?
TPL.
Oh.
You know what? I'll make it nice and big so it's easier to see. Okay. So what we're going to do is we're going to be assuming that capital is fixed, and we're just going to be varying our amount of labor. So let's just do, oof, that's bad. Let's do an example here. So there's labor, and here's my total product of labor. A nice, easy way to think about total product of labor is quantity. Okay, how much stuff are we able to produce? Okay, so I don't know, give me some product out there. Any ideas? Ice cream. Okay, so let's say we're talking about ice cream. So here what we're talking about are ice cream workers. I have a fixed ice cream factory. Okay, I have a factory of a certain size. I can't do anything about it right now. In the future, if I wanted to, I could build a new factory if I wanted to. But for right now, okay, I'm not able to do that. So if things are going very, very well, even though I want to, I can't build a new factory right now. The other side of that story is true too. If things are going horribly and my ice cream factory or my ice cream store is just going to hell, I'm sorry to say I can't close down my business at all either. Because
what does that R mean?
Because of the contract.
Because of the labor contract. Because of the rental contract. I can't do anything about that. Okay.
And that's what the R stands for.
Where's the R?
I don't understand.
It's a A.
Sorry. The P.
Okay.
Sorry, my handwriting is usually better than this. It's just the whiteboard that makes it a little bit messy. Okay, so here we're talking about the ice cream workers. So the total product of labor means how much ice cream they're going to be able to produce. So if you understand that, then this should be easy. With 0 workers, how much is the total product of labor?
0.
Yeah, 0 workers means 0 production. Well, I have 0 workers. How many factories do I have?
1.
I still have this
1 or
fixed
2.
amount. I still have this one amount of factory, let's say. But what am I going to do with 1 factory and 0 workers? No production. Okay? But here's the thing. What happens if I have 1 worker? Let's say they're able to produce 10 ice cream cones. What happens if I have 2 workers?
20.
Here's the thing. Maybe it goes up to
15.
30. We'll talk about that. We'll talk about that in a little while. I know it seems
But
weird that
then-
1 worker could do 10 ice cream, but 2 workers could do 30 ice cream.
It
Maybe
motivates themselves.
3
They get
workers
motivated.
could do 60 ice cream. Holy
But
crap.
then when like they don't fit, it's going to go down each one. Right?
You guys are already understanding the common sense behind this. Good. So with the 4th worker, let's say I'm only able to get out, I don't know, maybe 75 ice cream in total. With the 5th worker, let's say I'm only able to get 80. And with the 6th worker, now let's make it easier. Let's say with 6, I'm able to get 80. With 7, I actually get
80. You still get like onto.
Yeah, let's say something like this. What the crazy? I'm hiring more workers, but I'm getting less production.
It's like marginal.
Because there
I
is
like
not
what
a
you
lot
say.
of space.
I like what you said there. It's like marginal.
Because there aren't enough resources.
Let's talk about this guy. Marginal product of labor. I didn't even give you the equation for this, so why don't you give it for me? Whenever I talk about marginal, the idea that pops into your head should always be triangle.
So
Labor,
amount over total.
the change in labor over the change in total production.
Close.
Total product. Total
Very
product.
close. It's the change in the total product of labor over the change in labor.
Yeah.
Interpret that for me. What does that mean? The change in the TPL over the change in L.
The change in how many you make
Uh-huh.
over the change of the workers.
Uh-huh. So
People
what that
make-
actually shows you is the extra production that 1 more worker can do for you. Okay? This last worker that you hired, how much extra production he's able to do. All right. Let's do it. So first of all, with 0 workers, MPL is undefined. You can't do MPL there because it's kind of like you're going from -1 worker to 0 workers. Can't do that. But let's say we go from 0 workers to 1 worker. What was the extra production?
10.
Okay, so what that means is that first worker was able to do 10 extra ice creams. What about that second worker? How much additional ice cream do I get there?
20.
That second worker was able to get 20 more ice creams. He was able to produce 20 more. What about that third worker?
30.
He was able to do 30 more ice creams. You see something weird going on here? Why is it the case that every new worker is able to do more than the previous worker? Why was that second worker more productive than the first? The third worker more productive than the second?
Because there's more people.
Wait,
Then why wouldn't it be the case that 1 worker does 10, 2 workers do 20 in total, 3 workers do 30 in total? Why isn't it the case that each new worker brings in an additional 10 ice creams?
Because there's a
Because
fixed
teamwork
space.
makes the dream work.
What was that?
Teamwork makes the dream work.
Absolutely. That's the perfect answer. Teamwork makes the dream work. I'll show you that in a little while.
That's common sense.
Yeah. So it seems like teamwork just makes the situation better, but what's going on with this fourth worker? How much extra is he able to do?
15.
Uh-oh. It looks like teamwork is not working anymore. What about this guy? What about the fifth worker?
5.
Now, what happened with the sixth worker?
It stayed the same.
So what that shows you is that sixth worker did absolutely nothing to your production. He didn't add anything at all. But what happened with the seventh worker?
He worked hard.
What happened with the seventh worker?
It's negative 30.
He intervenes, like he,
Yes.
Not intervenes, he interferes.
There is not enough space for people to work.
Good. Okay? Now, all of these workers, let me tell you something. They're good workers. They're not lazy or anything. They're not trying to be bad workers. They're doing their best. But we're not giving them a fair chance because of this guy.
And how do you change that then?
You want to know how you change that? Give them more factory space. But the thing is, we can't do that in the short run because by definition, in the short run, we cannot change up the factory space. So the
We
idea...
need to wait till the long run, right?
Yeah. Wow. Okay, you guys are doing very good. Okay, it usually takes students a lot longer to figure out what the crap is going on here. So let's try this. Okay, let's say this is my ice cream, and let's call it my ice cream store. Okay, let's call this James's Ice Cream. Not very creative. Okay, so there's my ice cream restaurant. So first off, with 0 workers, even though I have this big old store, how much ice cream am I producing?
0.
Yeah, I don't have any workers here for my capital. Okay, so 0 production. But now let's say I hire my first worker. What color should I make this worker? Let's say I hire my first blue worker. Okay, so this is now worker number 1. How much additional ice cream is he able to produce?
10.
10 additional ice creams. Fantastic, good for him. But for that second worker, how much additional ice cream is he able to produce?
20.
So why was the first one only able to make 10, but the second one was able to make 20?
When they work together,
They split jobs, so each one does like one part, so it helps them.
Fantastic.
Like,
Because
maybe
in this
one-
ice cream store, okay, what happens is there needs to be somewhere in the back working the kitchen. Okay, making
someone
the ice
wants
cream.
it,
Okay,
someone sells,
there needs to be somebody.
someone sells ice
okay.
cream.
There needs to be somebody waiting on all the customers. Okay, so there's the chairs and the tables.
Someone in the front.
Okay, and there needs to be someone in the front working the cash register as well. So when it was just this one worker, he had to do everything. Okay, he had to take the orders, then he had to run back and make the ice cream, and then he had to come back, serve the ice cream, and then he needed to work the cash register as well.
But Mr. James, it's not like the second worker can do 20, but like they both
Mhm.
can do 20. Like one worker can do 10, but like 2 together, a teamwork can do 20, not just like the second one alone.
No, because
2 together can make 30.
Yeah.
The second one can do an additional 20.
Okay.
Okay? Yeah. So what they're doing is, they're doing what we discussed way back in the beginning of microeconomics when we talked about the butcher and the farmer and the rancher. What they're doing is, they're splitting up the jobs. They're specializing. You do what you're good at. I'm going to do what I'm good at. We figure out our comparative advantages. Let's say for one of these guys, they're better at waiting on the tables. They're just more personable and they like working with people. Okay? So they're going to do the waiting and they're going to do the cash register. The other dude, he doesn't like speaking with people at all. Okay? He just wants to go in the back and just make ice cream after ice cream after ice cream after ice cream. So they do what they're good at. Same thing
So
with
it
this.
is like, so it is like this, like when you add more workers, your company is more productive, but if you add too much workers, it will make them do less because there isn't enough space for everyone and for everyone to work and be productive.
That's it. That's the basic idea. Okay, so for this third worker, he's able to do an additional 30. Okay, I know these numbers. I should have picked better numbers. Okay, I'm not saying that one worker could do 10, 2 workers could do 20, 3 workers could do 30. Because then everybody would be exactly the same. What I'm saying is the first person could do an additional 10. The second person could do an additional 20. The third person can do an additional 30. Each new worker is getting more and more productive because, well, with this third worker, now they completely specialized. One person does the waiting. One person does the ice cream making, and another person works the cash register. They all have their jobs. So
this like when you maximize your in the consumer theory, it was that when the marginal utility is at zero is that when you maximize
Mm-hmm.
your total utility. So in this case,
Uh-huh.
when your marginal product labor is at zero, then you maximize your total product labor.
Perfect. So what you're going to realize about econ is we talk about the same story, the same situation, but under different circumstances. So we talked about consumer theory and people trying to make themselves as happy as possible by maximizing their total utility. But total utility is going to be maximized when marginal utility is equal to 0. Here, for the company, they're going to try to make themselves as happy as possible, not by maximizing their utility, but by maximizing their production. They want to produce as much of this ice cream as possible. So what they're going to do is they're going to focus not on the total product of labor. That's a little bit too difficult. They focus on the marginal product of labor. Okay? They love it to be the case that marginal product is going to increase and increase and increase, where each new worker is more and more productive, where teamwork makes the dream work. They're splitting up the jobs. But what they realize is eventually there comes a point, like with this fourth worker, that the MPL starts to go down. This fourth worker is only able to do 15 extra ice creams. Does that make him a bad worker? Not necessarily. He's still increasing your ice cream production. He's still making your company produce more ice cream. Just not as much as the third worker, not as much as the second worker. Okay? So this fourth worker is still good for your company. He's just not as good. And the reason for that, I mean, if we look at the common sense here, there's 3 jobs to do. This fourth worker, what they do is they kind of tag out. Okay, so if one of the other guys gets tired, then this guy just swaps in. But for most of the day, he's just waiting around and just helping out here and there. Okay, but he doesn't have his own set job. Okay, now what we're doing here is we're talking about all the different scenarios, all the different situations. If I had 1 worker, if I had 2, if I had 3, if I had 4, and on and on and on. There's nothing to say that I would hire 20 workers or 50 workers or 100 workers. Okay, those numbers just wouldn't work out. It just wouldn't make sense. Okay, but what we're doing is we're talking about if we did this, if we did this, if we did this. So if I hire that 5th worker, now what was the MPL of that 5th worker? It was 5. So again, he's still adding something to your production, but he's only making you 5 more ice cream. Maybe he's not worth it. Okay, if you want to see if he's worth it or not, we need to talk about how much you're paying this guy. Okay, but we'll leave that story out for now. Okay, we're just talking about how much this guy is able to produce. He is able to produce for your company 5 more ice cream cones. He is doing something. But what goes on with that 6th worker? What's a good color now?
So it all depends because since there is more workers, there's less space, and so that is why, like, the increasing decreases, something like that.
So you see, with that 6th worker, because it is getting so crowded, he's not doing anything much at all. Okay, everybody has a job, and you can think about it as everyone has a backup worker as well, who's willing to switch in when one of those guys gets tired. But for that 6th worker, he's doing absolutely nothing. He just sits around all day and he doesn't really add to your production at all. And with your limited capital, with your limited space here, if for whatever reason you decide to hire another 7th worker, now his marginal product is going to be a minus 30. So how does it make sense that hiring another person actually decreases your ice cream production?
There's not enough space
Exactly.
for him to stand around.
It's not even that there's not enough space. It's so crowded that as soon as you produce some ice cream, okay, that worker turns around, and because there's so many people in the store, he bumps into somebody and he drops that ice cream on the floor. So that additional worker actually caused so much of a space problem that your production is actually starting to go down. Okay, so we'll see this pattern happen all the time. Okay, at first, when you first start hiring these workers, it's usually going to be the case that marginal product is going to start to rise. That's increasing MPL. And I'll tell you what, that's going to happen because of teamwork makes the dream work. It's going to happen because of something called specialization. Okay, you guys are working together. There's this what we call synergy. Okay, it's where the total is greater than the sum of the parts. You guys are helping each other out. But there also comes a point where MPL starts to go down. Again, MPL going down, I mean, it's not necessarily a bad thing. Okay, I know it means that you're not the most efficient, but you're still increasing your production. It should be here.
So you get your workers until your marginal profit is positive.
But here we're
I
not
like that.
here we're not taking account like the wages.
Mhm.
Right?
And the thing is, we're only looking at one of these resources. Okay, so we could talk about the total product and the marginal product of milk. We could talk about the total product and marginal product of strawberries and sugar and all of these other resources. So for here, we're just focusing on one of the resources, the labor. Okay, so this is only a very, very small part of the story, but it'll help us to understand the bigger part later on. Okay. So here we see for the fourth worker, the fifth worker, maybe the sixth worker, our MPL is going down. There's starting to be some overcrowding. Okay, so people are bumping into each other. The marginal product is starting to go down. But as long as your marginal product is positive, that means that worker is still doing something for your company. Okay, but if the marginal product ever dips down into the negative, marginal product labor is negative, okay, then you know for sure you would never, ever, ever hire this guy. No matter what your wage rate is, you would never hire this guy because he's actually bringing your production down. Okay, there's so much overcrowding going on that everyone is bumping into each other and less ice cream is being produced.
But will you hire the sixth or no?
Okay, my simple answer is we don't know yet. Okay, the more proper answer is no, hell no. Okay, the reason is we need to pay that guy something, right? If we're paying him something, but he's doing absolutely nothing for my company, then what that means is my company's going to be losing money on this guy. Okay, but again, I'm not going to be sure how much that is until I figure out how much I'm paying these guys. That's the other part of the story. We'll come back to that. We'll circle around back to that pretty much at the end of microecon when we start talking about the factor markets. Okay, I like the way you guys are thinking. So, do you guys understand why MPL will rise at first? Because of specialization. Do you understand why MPL would fall after that? Because of overcrowding. So there,
everybody has their duty.
yeah. Okay, that doesn't necessarily mean that a company should be trying to maximize their marginal product of labor. No. Okay, I know that this third worker is probably the most efficient, the most effective, but I'll probably hire 4 or 5 workers. Okay, even though I know that the fourth or the fifth worker is not as effective, not as efficient as the third, because I just want to produce as much as I can. Okay. Oh, good discussions. So we talked about the total product of labor. Okay, and we talked about how it might be easier to think about the marginal product of labor. Remember, in econ, we always do marginal analysis. Okay, we're going to try to figure out how much each new worker is able to produce, and we're going to compare that with how much we need to pay each new worker. We're just going to compare those guys out. Okay, something else we could do is take a look at the average product of labor. Take a look at this equation for MPL. Take a look at this equation for APL. Very, very similar, but what's the difference? For the MPL, for any sort of marginal, we always look at the change. Yeah, okay. With the average, all we're doing, I mean, think about average. You do average in schools all the time. Okay, you just take a look at the total divided by how many there are.
Right.
Yeah, okay. Yeah. So we're just looking at TPL over L. And take a look at what's going on with your average product of labor. Let me get rid of some of this stuff. You understand the story about the ice cream stand, right? Hopefully. Okay, it was actually a fairly easy story to understand.
This one was a very good example.
I'm sorry to say, it's not mine. We use that story all the time, okay, because it makes this idea of changing marginal products easy to understand. Then we could talk about our APL. Okay, average product of labor was just total product divided by labor. It's just our average. Okay, so first of all, with 0, it's undefined. Okay, because 0 divided by 0 makes no sense at all. Then all we're going to do is, for that first worker, we're going to do 10 divided by 1. So our average is 10. That second worker, we're not talking about how much additional he's able to do. We're just talking about, okay, 2 workers can make 30. So on average,
15.
3 workers could do 60. So on average,
20.
okay, and then this is where it gets ugly. What is that? 1 and then 35. So that's around
15.
8.
No more.
18 around. Okay, and then for that fifth work,
18.25.
don't do that to me. I don't want to do all these numbers properly. I'm just going to do it in my head. So 16 and then 1 and then 20. So that's like 13.
13.3.
And then 7 with 50. So it's around 7. Okay. So take a look at the overall pattern of your MPL. It goes up for a while, and then it starts to go down. Take a look at the overall pattern of your APL. It goes up for a while, and then it starts to go down. It's actually for exactly the same reason. It's going up for a while because of specialization. Everyone is splitting up the jobs. And then it starts to go down because of overcrowding your fixed capital. But if you think about it, what moves a lot faster, the marginal or the average?
The marginal.
Yeah, because with the marginal, you keep on looking at the next one, the next one, the next one. You're looking at each new one separately. But for the average, you're looking at everything all together. Okay? So everything all together will change, but it's going to change a lot slower than the marginal. Okay? You could think about the average as kind of trying to catch up to the marginals. Okay? So, in general, what we do understand is, for the marginal, it's going to go up for a little while because of that specialization, and then it's going to dip. It's going to go down because of overcrowding. That happens so much that we call this the law of diminishing marginal. I would love to say the law of diminishing marginal product, okay? But we actually call this the law of diminishing marginal returns. Same idea. Okay, some people might call it the law of diminishing marginal product. Okay, but we'll call it the law of diminishing marginal returns. Okay, what that means is, after a little while, after that little blip of specialization, each new resource, each new worker is going to start bringing you less and less additional production because we're overcrowding our fixed capital. Okay, diminishing marginal returns. Very similar, I guess, to that idea of diminishing marginal utility. Okay, so we have.
Can you repeat that, because I'm writing it on my notes.
I think I wrote it down somewhere. The law of diminishing marginal returns. As successive or as additional units of a variable resource, in our story, it's going to be labor. Oops. They are added to a fixed resource. In our story, that's going to be capital. Beyond some point, we say beyond some point because for a little while, MPL does rise because of specialization. Okay, but beyond some point, the marginal product is going to start to fall. Okay, and the marginal product falls because of overcrowding. Okay, so every part of this definition, I know it sounds a little complicated, but you guys understand it. Okay, as additional units of labor are added to a fixed capital after we have a little period of specialization. Okay, after we have a little bit of marginal product increasing, then overall marginal product is going to fall because of overcrowding.
Does this happen with only in the short run?
Good. Only in the short run. Okay, because technically in the long run,
You have space.
We have space. In the long run, do we ever have fixed resources? No. In the long run, our labor is variable, but our capital is variable as well. In a long enough time period, we're not going to have this overcrowding problem, because what happens if there's going to be too many workers for a factory? In the long run, build a new factory. Okay? So you're not going to have that overcrowding
It
problem.
isn't realistic.
Is it
The
realistic?
long run isn't realistic.
I would say so. Okay? What I would say is we live in the short run. Okay? So every company out there just needs to deal with what they have. And it's usually the case that they could hire workers very quickly, but how many factories they have is how many factories they have. I always think about companies like Amazon. Huge factory, or a huge company, right? Okay, but even for that huge company, they cannot build a new factory. They cannot build a new headquarters or new building right away. What they need to do is they just need to think about, these are how many buildings, these are how many factories we have. We need to think about how many workers to put into there, because it's very easy to hire new workers. You just put a
Don't you
posting on
think
Indeed
that,
and we could hire them.
like, the short run is much more like motivating? Like, I don't know.
I don't want to even say motivating. It's just that we live in the short run. We need to make decisions based on short run. But you always need to plan for the long run. Okay? Because even when companies like Amazon are planning for 10, 15, 20 years in the future, they're thinking about how many workers should we be hiring, but they're also thinking about how many factories should we be building around the world. Okay? So we live in the short run, but always plan for the long run. Okay? So we skipped this little part. Okay? So here are some other numbers for TPL, MPL, and APL. And we're talking about hot dogs here, but we notice the same thing. Okay, for the total product, we see it going up for a little while. It's maximized here, and then it starts to go down. For my MPL, we see it rising for a little while, and then it starts to go down. And I guess another section is it's negative. So first of all, when your MPL is rising from 5 to 10 to 15, what's happening to your TPL? If your MPL is increasing, that means your TPL is rising at a faster and faster rate. It's increasing quicker. But
increasing at an increasing rate.
Good. What does it mean if your MPL is positive, but it's decreasing?
Increasing at a decreasing rate.
Increasing at a decreasing rate. So as long as your MPL is positive, that means that your TPL is rising. Okay, your TPL is increasing. That means that worker is adding something to your production. That worker is making more hot dogs.
Yes,
but if
my
your
presentation
MPL is
teacher told me that, last week that on the consumer theory that it increases at a decreasing rate, because like it doesn't increase and keeps increasing more. It decreases a little bit. But it's still increasing until the
good way to think
it's
about it
maximized.
is this increase, it's still happening, but it's starting to slow down. Okay, the increase is starting to slow down. When your MPL is finally negative, as long as it's negative, that means that your TPL is falling. Your TPL is getting smaller. And what we see here is your MPL is actually getting more and more and more negative. If your MPL was always -5, -5, -5, that means every single new worker is bringing your production down by 5. But since your MPL is going further and further negative, that means each new worker is dragging down your production even faster and faster and faster. Okay? And what do we see for our average product? Well, for our average product, again, it's going to be the same overall general pattern as your MPL, meaning it's going to go up and then it's going to go down. But the average is going to be much smoother. It's going to be a lot slower. And here's the cool thing. Okay, what we know is your MPL, we're just looking at that last worker. So it could be the case that your MPL is positive. It could be the case that your MPL is negative. Can your average product ever be negative? technically,
Yes, like in a
Technically.
long run.
in a very, very long run, okay? Because what needs to happen is all of those negatives need to overall outweigh the positive, okay? So
you need to like your total product label needs to be negative.
your total product?
Like for the average to
Uh-huh.
be negative, I think that total product has to be negative.
Yes, okay, but it's not the case that as soon as total product becomes negative, that average product will be negative. Okay, total product needs to be negative for a long time before that drags the average down. Anyone taking calculus yet? No? Then you guys are very good, okay? Because you guys are already thinking in calculus terms. Okay, if you talk about increasing at a decreasing rate or decreasing at an increasing rate, all of that stuff is just calculus. Okay, so good job. So what we're going to do is we're going to graph these out. You know what? I don't want to graph it out like that. We're just going to do it ourselves. Okay. Sorry, I should do this. So here is, first of all, I'll talk about my TPL with respect to L. So on my horizontal is labor. On the vertical is my total product of labor. Okay, so let me show you what this looks like. Why don't you guys tell me first, where does my graph here start? Always think about where your graphs start.
Right.
Similar to the consumer tier.
Yeah, it starts there at the origin. Because with zero labor, how much ice cream are you producing?
0.
Zero. So I'm going to start there. Okay. Now it's going to what?
So it goes up and then it'll go like a bit down, like that.
Actually, no. It's going to look like this.
Yeah, a bit more realistic.
Wow, very weird.
Yeah. Okay. You'll see
And
this a
then
lot in
tomorrow-
calculus when you guys take it. Okay. There's going to be two very, very important points here. One point you can already see. What do we call that point?
The peak.
The peak or the maximum. You guys know that. Okay. There's actually
Is it
another
really-
very, very important point here. There's this point here. Okay. And this is something that you will learn in calculus later on.
The maximum rate.
Yeah, kind of. This is something known as the point of inflection. Point of inflection. What the crazy does that mean? It just means that your curve here, your graph, it flips from doing this to doing this. So instead of bending up, now it starts to bend down. So what this would mean is it's increasing at an increasing rate or a decreasing rate.
Increasing at an increasing rate.
It's increasing at an increasing rate. It's getting up faster and faster and faster. What about this? Is it increasing or decreasing?
Increasing at a decreasing rate.
It's increasing at a decreasing rate. It's still going up, but it's going up slower and slower. And then what about here?
Decreasing at an increasing rate.
Yeah, it's going down and down and down and down and faster and faster and faster and faster.
What would that graph look like the other half? It would just go down or have a curve, another curve?
For the TPL,
Yes.
I would
Yeah,
say it just
that's
keeps on
what-
going down like this until it goes down for forever. Okay, because, you know, if your company, if your factory is already overcrowded, what happens if you just keep on stupidly just adding more and more workers there? You know, I mean, it's going to get so full that everyone is up next to each other and you're not going to be able to produce anything. Okay, so I guess it would just, I guess you can't have negative production. It would stop there. You would have so many workers that it just shuts down your production completely.
The max would be where the marginal product is zero.
I like the way you're thinking. Because right below this, we're going to show our MPL curve.
And then they connect, right?
Well, kind of connect. Okay, they are very related to each other by this point here called the point of inflection, and by this point here called the maximum. Because what you remember is, what's the equation for MPL?
The
Change
change
it.
of
Change
total product
price
label
of-
over the change of label.
over
Careful, not total price. What does P stand for here?
Product.
Product. Okay, the change in the total product of labor. Easy way to think about that as a total production. How much those workers are able to make. So the change in the total product of labor over.
The change in labor.
Good. Or go back to your 4th grade math class. The change in this over the change in this is called? What's the
Slope.
change in the y over the change in the x? The slope. Okay? The MPL is the slope of TPL. You'll learn this later in calculus. We'll actually call this the derivative. The MPL is the derivative of TPL. It's the rate of change of your total product. Rate of change is exactly the same thing as slope. Okay, so you guys know it as slope, but now we're going to think deeply about what slope means. Slope means how much something is changing by. So here, can you tell me, is the slope at first positive or negative?
Positive.
Positive. It's a
No.
positive slope. Okay, but tell me about that slope. Is the slope getting bigger or is the slope getting smaller?
Smaller.
Bigger.
Bigger. The slope is positive and it's getting bigger. The
I
slope is
meant when you will go to a maximum point.
the slope is positive and it's getting bigger. Tell me about the slope here. Is it positive or negative?
Positive.
Positive. Is it getting bigger or smaller?
Bigger.
Ooh.
Smaller.
Think about these lines here. That's touching this curve.
Going to the right, yeah, smaller.
Yeah, it's still positive, but it's getting smaller and smaller and smaller. Now think about this. At the very tip top, what's the slope there?
Negative.
There isn't a slope.
There
It is
isn't
zero.
a slope. It's 0. At the very, very tip top, okay, it's going to be equal to 0. That's what the MPL is there. Okay, and then afterwards, what can you tell me about the slope? Positive or negative? Going down. And it's actually going more and more down. So the MPL is negative and it keeps on getting more and more negative.
So that's the graph for the MPL.
Yeah. So it's actually very easy to graph your MPL from your TPL. Just from these two very important points. The point of inflection. I could give you that name, point of inflection. Just think about it as the flip point. Okay, that flip point is going to show you where your MPL is maximized. And then the tip top, the maximum of your TPL is where your MPL is equal to 0. Because if you think about it, no matter if it's increasing or decreasing, if your MPL is positive, meaning it's above the x-axis, so here MPL is positive, here MPL is positive as well. Whenever your MPL is positive, what's happening to your TPL?
It's increasing.
It's increasing. But what happens if your MPL is negative? What's happening to your TPL? It's decreasing. Well, if you know that, so here's where TPL is going up, and here's where TPL is going down. Well, if your MPL is exactly equal to 0, it's not going up anymore, but it hasn't started going down yet. What do we call that? It stopped going up, but it hasn't gotten down.
The maximum point.
It's the maximum. It's the tip top. Okay? It's not going up anymore, but it hasn't started going down yet. It's at the very, very tip top. Okay? So, when your MPL is 0, that's where your TPL is maximized. Where your MPL is maximized is the point of inflection on your TPL. You don't need to worry about that one all too much, but you need to make sure you understand that these 2 points are going to be lined up to each other. Now, I'll just leave you with one more. Okay, if this is what your MPL looks like, up and then down, what is your APL going to look like?
The same.
The same, but a lot slower, a lot smoother, because we're looking at all the data all together. It's an average. your APL is going to go up and then down. It's going to look like this though. Up and then down. We'll talk about this tomorrow. But where they intersect, where they cross, must be
But at the beginning, it's
the maximum of APL.
not. At the beginning, it's more like the MPL because it's one.
Oh yeah, at the beginning, technically they should be touching. Okay, but where they intersect again will always be at the maximum point of APL. Okay, not a coincidence. It's a mathematical fact. It has to happen there. Okay, and they bring up this point in econ test all the time. We'll talk about it tomorrow. We'll talk about why that needs to be there. Okay, good job for today. I think you built the understanding, the logic behind the scenes. Just think about that ice cream store and how crowded it's going, or the ice cream store and how they're splitting up the jobs. And now you're starting to understand the math behind it as well. Okay, so that these graphs, I know at first it might look a little confusing, but trust me, there will come a point where you don't need to draw this guy from memory. You don't need to remember what it looks like. You could just think about the concept and kind of piece it together. Okay? All right, we'll continue on with this tomorrow. By the way, next week, I'm actually going to be out of town. Okay, so we're not going to have any lectures next week.
Yeah, it's Carnival. It's Fiestas Patrias here in Panama. So
Yeah, so I think I lined up my vacation for your holidays as well. Okay, so there will be no lectures next week. Are you guys going to be able to make your recitation classes? Yes? No?
I think I will be.
Yes, I think I can.
Okay.
Yeah.
All right, so I'll try to think of some review material for you guys to go over. There won't be... I'll think about it. We'll see. I'll let you know tomorrow.
So this was very similar to the consumer theory. In the same concept.
What you'll realize is consumer theory and producer theory are like, your right hand and your left hand. They're very much connected to each other. Okay. All right. I'll see you guys tomorrow.